Yes, welcome children. I'm your Raj sir. You are in JS Academy, Hyderabad Junior Scientist YouTube channel. Yes, today our topic ICSE Energy Lesson, Chapter 4. The ICSE or State Board Energy Concept Physics is same. Okay. So if you want to learn about energy, work done, potential energy, kinetic energy, power, then you can follow this. Yes, children. So just I am keeping in front of you a learning objective is work. Means so after this lesson, after this teaching, you able to understood about the work and you can give the SI unit of work and you can write the formula of work and you can do the problems. Able to do problems based on work. These are our learning objectives. So I am taking a concept topic work. See children. So only short video this one. Listen. Here energy I say see okay. Work. What is mean by work? Homework. Is it treated as scientific work? Here the person standing with the heavy weight. Is it treated as work? Is waiting for 2 hours, 3 hours in a bus stop or railway station. Okay, this comes under scientific work. The person is pushing heavy weight, big stone, but it's not moving. But even though he is applying force, but it is not moving. Here also person is at rest. So these two situations can we treat as work has done? So in these two cases, no work has done. No work has done. The homework also we don't treat as scientific work. So talking, speaking, speech may not treated as work. Okay. So what is the scientific meaning means? So very simple. See, I am applying force on the board. It's not moving. Work has not done. Okay. So I will show you one activity. For example, I have a writing pad and I have one object here. See, I am applying force by using my hand. Right. So here what happens? It is moving. What here what are the observations? Very clear observations too. One is force applied and force applied on the object in this direction, and the second observation is this object was displaced from this point to and this point. So object displaced means what? Shifted, moved. ఓకే ఒక ప్లేస్ నుంచి ఇంకో ప్లేస్కి అది కదిలింది అనమాట. ఓకే సో ఓన్లీ టూ థింగ్స్ హ్యాపెండ్ హియర్. వాట్ ఆర్ దోస్ మీన్స్? సో ఫస్ట్ థింగ్ ఈస్ force applied. Force is applied. Force is applied on the object, and second thing is it was displaced. It was displaced. Force is applied and it was object was displaced. Two things we have observed, right? Here also I am giving the diagram. Object have mass m. Force is applied means in the direction of, this is the force direction. In the direction of force, the object displaced from point A to B. Then work is said to be done. వర్క్ జరిగింది అంటాము. ఇక్కడ టూ థింగ్స్ జరగాలి. ఏంటి? ఫోర్స్ అప్లై చేసిన డైరెక్షన్లోనే ఆబ్జెక్ట్ మూవ్ అవ్వాలి, డిస్ప్లేస్ అవ్వాలి, A to B displaced. So very simple work definition. Work is defined as work denoted with W. Our learning objective is work. So now we are learning the definition of work. So work is defined as it is the product of, short definition, it is the product of force and displacement. Short definition, it is the product of force and displacement. Displacement you may take it as D or S, that is your wish. So in ICSE given that is D. Actually displacement in physics we have to represent S bar. Okay, S bar vector quantity S లో చూపించాలి. ఓకే సరే D ఇచ్చాడు తీసుకుందాం. Displacement is D, it was shifted from here to here. Force is applied F. Alright, work W is equal to force into displacement కదా. సో మరి లాంగ్ డెఫినేషన్ ఏంటి? ఫోర్స్ అప్లై చేస్తున్నాము, ఫోర్స్ వెక్టార్ క్వాంటిటీ ఏ డైరెక్షన్లో అప్లై చేస్తున్నాము, ఓకేనా. సో మనం వచ్చేసి ఏ డైరెక్షన్లో అప్లై చేస్తున్నాం అనేది కంపల్సరీగా మనము చెప్పాలి. అంటే ఫోర్స్ నేను వచ్చేసి ఓకేనా ఈ డైరెక్షన్లో అప్లై చేస్తున్నానా, లేకపోతే ఈ డైరెక్షన్లో అప్లై చేస్తున్నానా, ఈ డైరెక్షన్లో అప్లై చేస్తున్నానా, ఓకేనా, అప్వర్డ్ అప్లై చేస్తున్నానా, డౌన్వర్డ్ అప్లై చేస్తున్నానా, ఆబ్జెక్ట్ పైన ఫోర్సు ఏ డైరెక్షన్లో అప్లై చేస్తున్నాను అనేది మనము ఇన్ఫర్మేషన్ అనేది ఇవ్వాలి, ఓకేనా. సో ప్లస్ అది ఏ డైరెక్షన్లో మూవ్ అయింది కూడా మనము డైరెక్షన్ ఇస్తున్నాము, ఎఫ్కి డికి. ఓకే, సో ఫ్రమ్ దిస్ సినారియో ద లాంగ్ డెఫినేషన్ ఈజ్ జస్ట్ డైరెక్షన్తో యాడ్ చేస్తే ద వర్క్ డన్ బై ఏ ఫోర్స్ on a object is equal to the product means into product of the force applied and distance moved by the body in the direction of force. Okay, so simply you can write work is defined as it is the product of applied force and displacement. Okay, you can write. So F into D is the formula, force into displacement. Then formula definition finished, formula finished. Next SI unit. So SI unit is force SI unit is Newton and distance SI unit is meter. Then it is Newton meter is the SI unit of work. Then if 1 Newton force applied on the object, 1 Newton force applied on the object, it displaced 1 meter. If it displaced 1 meter, then we can say that 1 joule work has been done. Okay, 1 Newton force apply చేస్తే మనకు ఆ ఆబ్జెక్ట్ వచ్చేసి 1 మీటర్ మూవ్ అయితే మనం దాన్ని ఆ వర్క్ని మొత్తాన్ని మనం 1 జౌల్ వర్క్ జరిగింది అంటాము. 1 joule work has been done. So finally this another unit is joule. SI unit of work is also known also joule. 1 joule is equals to 1 Newton into 1 meter. Okay, so 1 Newton into 1 meter also we can write 1 joule. Alright, so here definition finished, formula finished, SI unit finished, definition finished, SI unit formula finished, and let us do some problems. Numericals problems. So very simple. You know how to solve the problem. So our style is, this is the simple way, 6 steps. GFF SSC, given, find, formula, substitution, simplification, conclusion. G means given. So here let us see the question first. If 10 Newton force, 10 Newton force applied, 10 Newton force applied on the object, anything you can take. 10 Newton force, if 10 Newton force is applied on the object and it is displaced and it is otherwise and it was displaced and it was displaced and it was displaced 5 meters, 5 meters in the direction of applied force, in the direction of applied force. Then find work done. Then find work done by the applied force. Then find work done by the applied force. Right, children. So now see here. First G means what? Given. What is given in the question? Question లో ఏమి ఇచ్చాడు? సో ఒకసారి చూడండి, ఇక్కడ 10 న్యూటన్, ఇక్కడ వచ్చేసి మనకి 10 న్యూటన్ యూనిట్ ఐడెంటిఫై చేసిన మీకు అర్థమైపోతుంది. తర్వాత ఫోర్స్ అయినా ఉంది, న్యూటన్ ఫోర్స్ యూనిట్. సో గివెన్ క్వాంటిటీ ఈజ్ ఫోర్స్, గివెన్ క్వాంటిటీ ఈజ్ ఫోర్స్. కన్సర్న్ లెటర్ ఫోర్స్ ఎఫ్. సో వర్డ్లో ఉండాలి గివెన్ క్వాంటిటీ, ఫిజికల్ క్వాంటిటీ లెటర్లో ఉండాలి, ఈజ్ ఈక్వల్ టు మెజర్మెంట్ ఉండాలి, దానికి ఎస్ఐ యూనిట్ కూడా ఉండాలి. ఇక్కడ 4 పాయింట్స్ ఇంపార్టెంట్. Physical quantity, concern letter denoted by the physical quantity, concern letter. Next magnitude and SI unit. Okay. Next what is given? Okay. You observe 5 meters annadu, the displacement. Okay. 5 meter displacement. So displacement is given here. Distance moved or displacement. Okay. Displacement may distance aina raj. Displacement is how much? D we are taking, or S we can take 5 meters. Displacement to 5 meters. Okay, state book lo S untundi, S raskochu. Okay na. So ikkada vachesi displacement 5 meters given, finished. Next word F means find. Em find out cheyali ikkada? What we have to find here? Find work. So ila trace cheskondi. We have to find work. Ever chesina work done by applied force. Work done by applied force is equals to, work done by applied force means concern letter is W, is equals to question mark. Right? So very simple way మనకు అయిపోతుంది చూడండి ఇక్కడ. నెక్స్ట్ వన్ ఈజ్ ఎఫ్ ఫార్ములా. సో వాట్ ఈస్ ద ఫార్ములా ఫర్ టు క్యాలిక్యులేట్ వర్క్? To calculate work, we know the formula work is equals to product of force and displacement. So next formula finish. Next S means what? Substitution. Here F D given, instead of F we are substituting 10, instead of D we are substituting 5. So this is nothing but substitution skill. Next simplification skill means you are performing 4 arithmetic operations: addition, subtraction, multiplication, division, odd mass rule, square root, whatever it may be. So that simplification problem solving skill is nothing but simplification. The substitution finished. Next S means simplification. 10 5 is 50. What is the SI unit of joule? SI unit of work is joule. So we can write SI unit is joule. 50 joule work has done. Next C means what? Conclusion. We have to write the conclusion. Therefore, therefore, question is find work. Find work done. Find work done. Find work done by the applied force. Here, find the work done by the applied force. Therefore, work done by applied force is 50 joules. Therefore, work done by the applied force is 50 joules. Can write 50 joules 50. So this is the total how to do the problem. Okay. So from this, I hope you understood what is work. SI unit of work is here joule and Newton meter also. Formula work is equal to force into displacement, and problems also it was cleared. Okay. Yes, children. Let us learn about the concept of energy. So what is mean by energy? We have energy. If we have food, we have energy. So we have different types of energies: chemical energy, potential energy, kinetic energy, electrical energy. Okay, different kinds of energies we have. Even though in our topic in fourth chapter ICSE 8th class energy, so we are discussing energy in the textbook. Here the concept delivery is very important. Here what is mean by energy means our textbook definition is a capacity to do work. Energy can be defined as energy is the capacity of doing work. Is the capacity of doing work. Means if you have energy, then only you able to do the work. You don't have energy, you may not do the work. For example, a person is under fasting. Okay, so at morning 6 to evening 6. At the time of evening 6, he unable to stand. He may not do his personal works also. What is the reason? The reason behind it is person he don't have energy, food energy, chemical energy. So that's why he unable to do the works. He unable to stand. He unable to walk. Okay. Here the capacity to do work is nothing but energy. Right? Without energy, so no work will be done. In the sense, here energy means here ability to do work. Examples, here bike is there. So without energy, it doesn't move from one place to another place. Bike, any vehicle you can take. Okay. So on the ground, in our daily life, we are filling the fuel, that is not my chemical energy we are using, okay, to do work, to displace from one point to another point, right? Next, SI unit of work, SI unit of energy is also the same as SI unit of work. SI unit of energy is also joule. Joule we can denote as capital J. Next, most very important here, the energies are, so the mechanical energies. Mechanical energies are mainly two types. Those are potential energy and kinetic energy. Potential energy and kinetic energy. potential energy, kinetic energy. So what is mean by potential energy, what is mean by kinetic energy, we'll discuss. So not as per textbook, let us go for live examples, okay, live examples. So water stored in the tank, overhead tank, then the water has energy, means that water in the overhead tank, so what we can observe here, this water is also a matter, it has mass and it is at certain height h from the ground. A person who is in second floor or third floor in the building, okay, so here what we can observe, say heavy rock is coming, falling from the hill or a peak. So which type of energy it has at the peak level, okay. So we can see here also the object is at certain height. హైట్ లో ఉన్న ఆబ్జెక్ట్స్ అన్నింటికి పొటెన్షియల్ ఎనర్జీ ఉంటుంది. సో వెరీ సింపుల్ పాయింట్. హైట్ లో ఉన్న ఏ ఆబ్జెక్ట్ కైనా సరే, మనము ఫస్ట్ ఫ్లోర్కి వెళ్ళినా సరే మనకు పొటెన్షియల్ ఎనర్జీ ఉంటుంది. ఫస్ట్ ఫ్లోర్ నుంచి మనం ఒక 1 రూపీ కాయిన్ వదిలేసినా కింద పడుతుంది, ఆ కాయిన్కు పొటెన్షియల్ ఎనర్జీ ఉంటుంది. స్టోన్ వదిలేసాము, పొటెన్షియల్ ఎనర్జీ, స్టోన్కి అట్ దట్ పాయింట్ హైట్లో ఉన్న ఆబ్జెక్ట్కి పొటెన్షియల్ ఎనర్జీ ఉంటుంది. ఓకే, అండర్స్టూడ్? So in our textbook also given some examples. And one more thing, one more point is, by changing its position or shape చేంజ్ చేసినప్పుడు మనకి యారో తీసుకుంటున్నాము, యారో తీసుకున్నప్పుడు కూడా యారోకి మనం చేంజ్ చేస్తే, షేప్ చేంజ్ చేస్తే మనకు చేసి పొటెన్షియల్ ఎనర్జీ స్టోర్ అవుతుంది. Next, we can see some examples. Rubber band also, stretched rubber band. What we are doing here, we are changing a shape, right? Okay. Spring, elongated spring or compressed spring. So what you can observe here, there is a change in shape. Here there is a change in position. Position అంటే ఇక్కడ గ్రౌండ్ ఒక పొజిషన్ అవుతుంది, హైట్ ఒక పొజిషన్ అవుతుంది. If you observe the change in position, if you observe the change in shape, then those objects possess potential energy. It's clear? Next, for example, if you take the scale also. సో మీ ఫ్రెండ్ని ఇలా తీసుకోండి, ఒకసారి మనం బీట్ చేద్దామని ఇలా బెండ్ చేస్తారనుకో, ఇమ్మీడియట్గా దూరంగా పారిపోతాడు వాడు. వై? బికాస్ వదిలేస్తే తగులుద్దని తెలుసు వాడికి. నౌ దిస్ ఆబ్జెక్ట్, వాట్ ఐ హ్యావ్ డన్ హియర్, వాట్ ఐ డిడ్, I changed the state. Now it is straight line. So I am changing the scale shape. So I bent the scale. Scale bent చేశాను అంటే ఏం చేంజ్ చేశాను, దాని ఒరిజినల్ పొజిషన్ని, షేప్ని చేంజ్ చేశాను, షేప్ చేంజ్ చేశాను. సో నౌ వాట్ హ్యాపెన్స్, ఇన్ ది స్కేల్ పొటెన్షియల్ ఎనర్జీ స్టోర్డ్ ఆటోమేటికల్లీ. సో ఎలా వస్తుంది, ఎనర్జీ నైదర్ బి క్రియేటెడ్ నార్ బి డిస్ట్రాయిడ్ కదా. ఆ ఎనర్జీ నేను బెండ్ చేయడానికి ఎనర్జీ ఫోర్స్ యూజ్ చేశాను కదా. సో ఇక్కడ వచ్చేసి దట్ ఎనర్జీ ఈజ్ ట్రాన్స్మిటెడ్ ఫ్రమ్ మీ, నా నుంచి స్కేల్కి వచ్చేసింది అన్నమాట. ఓకే, సో వెరీ గుడ్. I hope you understood potential energy concept. Next, let us go to kinetic energy. Before going to kinetic energy, potential energy definition. Once let us see the potential energy definition. The energy possessed by a body, ఒక ఆబ్జెక్ట్, వాటర్కి అయినా సరే, స్టోన్కి అయినా సరే, ఇక్కడ యారోకి అయినా సరే, ఓకేనా. సో మనకి ఎనర్జీ వచ్చింది, ఎలా వచ్చింది, The energy possessed by a body due to its state of rest or position is called potential energy. State of rest, దాని రెస్ట్ వల్ల కానీ దాని పొజిషన్ వల్ల కానీ దానికి ఎనర్జీ వస్తుంది, దెన్ వీ కాల్ ఇట్ యాజ్ పొటెన్షియల్ ఎనర్జీ. ఓకే, రైట్. So here what is the formula for this means, here overhead tank, there is object, water is there, so water has mass and downward gravity is also there, mg, weight is acting downward. So if water reaches earth ground surface, then what happens, it was displaced, how much displacement, h. So work is equal to force into displacement. ఓకే, ఎస్ రాసుకోవచ్చు, డి అయినా రాయొచ్చు. ఎఫ్ అంటే ఏంటి, డౌన్వర్డ్ ఫోర్స్ ఏంటి ఇక్కడ, వెయిట్. ఆ వెయిట్ ఏంటి, డబ్ల్ అంటే ఇక్కడ వెయిట్. సో డౌన్వర్డ్ ఫోర్స్ వాట్, ఎంజీ. అండ్ హౌ మచ్ డిస్టెన్స్ ట్రావెల్డ్ ఫ్రమ్ ట్యాంక్ టు గ్రౌండ్ సర్ఫేస్, దట్ ఈస్ డి. దట్ డిస్టెన్స్ ఈజ్ హెచ్. So potential energy formula is derived conceptually like this. Force into displacement. Force, downward force, mass into acceleration due to gravity. F is equal to ma. A means acceleration due to gravity. And distance is h, height. mgh వచ్చేసింది. Very simple way. Next, kinetic energy. Kinetic energy. So kinetic energy means the object which possess motion, the object which has motion. ఏ ఆబ్జెక్ట్ కి అయితే మోషన్ అంటే స్పీడ్ ఉంటుందో ఆ ఆబ్జెక్ట్ కి కైనెటిక్ ఎనర్జీ ఉంటుంది. వెరీ 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 సింపుల్. కైనెటిక్, స్పీడ్ ఆర్ మోషన్. మోషన్ లో ఉన్న ఏ ఆబ్జెక్ట్ కి అయినా కైనెటిక్ ఎనర్జీ ఉంటుంది. ఎగ్జాంపుల్స్, వెహికల్ ఈజ్ మూవింగ్, then it has kinetic energy. Okay, so stone, bullet, moving stone, moving body, moving pen, moving pencil, moving aeroplane, moving vehicles. నువ్వు రన్ చేస్తున్నావు, the person is running, the person also have kinetic energy. Okay, scale is at rest, but scale under motion, so it has kinetic energy. So that effect we are getting pain here. So there is no motion, no pain. But if it has speed, then do some work. I hope you understood. Here, the bullet from the gun. Bullet from the gun. Then bullet has mass and it has velocity v. Okay. So it has mass m and it has velocity v. So due to this, it has some energy. Okay. For example, this object is traveling vertical height means it has both kinetic and potential energy. Height remains constant. If height remains constant, the object have only kinetic energy. If this object is traveling up or down, then at that time it has both potential and kinetic energy. height change, velocity తో పాటు height కూడా చేంజ్ అయితే రెండు ఉన్నట్టు. ఓకేనా, కాన్స్టాంట్ హైట్ లోంచి వెళ్తున్నప్పుడు ఓన్లీ కైనెటిక్ ఎనర్జీ. ఏరోప్లేన్ ఉంది, ఒకే హైట్ లోంచి వెళ్తుంది, సో ఇట్ హ్యాస్ ఓన్లీ కైనెటిక్ ఎనర్జీ. ఏరోప్లేన్ ఈజ్ నౌ ల్యాండింగ్, then it has velocity and its height is also changing, so possess both. And the object which is at certain height also has both potential and kinetic energy. But when we can say the potential energy is varying, height is varying, then we can say potential energy is varying, change అవుతుంది అని అర్థం. ఫిక్స్డ్ హైట్ లో ఉంటే potential energy constant, and because of velocity it gains kinetic energy. Okay, we have the derivation also for kinetic energy. The formula is, kinetic energy formula is half into mass into velocity square, half mv square. We have derivation in higher classes, you will get. In your textbook in 8th standard, it's not given. Once see here. Kinetic energy is equal to half mv square. Yes, children. Next. Here, factors affecting kinetic energy means what are the physical quantities here? Mass is there. Mass increases, kinetic energy increases. What does it mean? చిన్న బైసికల్ వచ్చి యాక్సిడెంట్ హిట్ అయింది, మే స్మాల్ ఇంజరీస్. అదే పెద్ద ట్రక్ కార్ వచ్చి హిట్ అయింది, మాస్ ఎక్కువ ఉంది, సైకిల్ అండ్ బస్ ఆర్ ట్రక్. సో మాస్ ఈజ్ మోర్ మీన్స్ మోర్ కైనెటిక్ ఎనర్జీ. ఓకే, నెక్స్ట్ వెలాసిటీ వి. ఓకే, సో మనకి చిన్న స్టోన్తో చిన్న కొట్టాము ఏం కాలేదు, బట్ బుల్లెట్తో ఫైర్ చేస్తే హై స్పీడ్ ఉంటుంది. Even though it is small mass, but here velocity is high. So high velocity, high kinetic energy, more velocity, more kinetic energy, both are directly proportional to kinetic energy, mass and velocity. What about here factors affecting potential energy? More mass, more potential energy. ఓకే, బిల్డింగ్ నుంచి 1 రూపీ కాయిన్ వేసాము, క్యాచ్ పట్టుకున్నావు బాగానే ఉంది, బట్ 10 kg స్టోన్ వదిలేస్తే పట్టుకుంటామా? No. Why? Because here mass is more, potential energy is more. And G also direct proportion. Here G is depends on Earth and other planets కి వెళ్ళామంటే మనకి G చేంజ్ అవుతుంది. So G is more, potential energy is more. G value we are taking 9.8 meter per second square. And H, height is more height, more potential energy. ఓకే, ఒక స్టోర్ని ఫస్ట్ ఫ్లోర్ నుంచి వదిలేసాము, సెకండ్ ఫ్లోర్ నుంచి వదిలేసాము, థర్డ్ ఫ్లోర్ నుంచి వదిలేసాము. So height increases, then potential energy increases. So these are the factors, and this is the explanation of potential energy and kinetic energy. So whenever the problem is given, here also SI unit, energy unit, energy unit, energy unit, total energy unit is joule only. Wherever electrical energy, what energy, whatever it may be, the energy unit is joule only. ikkada energy unit aina manaki joule. Next, formula different, SI unit same. So whenever the problem is given, then you have to identify the mass and velocity. You have to identify the mass and height and G. Then you have to substitute, then you will get the solutions. So this is the explanation about energy and potential energy and kinetic energy. Okay, next. Power also we have work and power. So here power is nothing but a rate of doing work. So let us discuss power. Now our learning objective is power. So what is mean by power? Power is denoted with P, and the SI unit of power is watt. WATT, watt. SI unit is watt. Watt. So 1 watt is nothing but 1 joule work or 1 joule energy has consumed in 1 second. In 1 second 1 joule energy consume అయితే దాన్ని మనం 1 watt అంటున్నాం. మన ఎలక్ట్రికల్ ఎనర్జీ కూడా ఎగ్జాంపుల్ తీసుకోవచ్చు. సో యాజ్ పర్ యువర్ టెక్స్ట్ బుక్, the definition is power definition. The power of a body is defined as the rate of doing work by the body. So power is nothing but rate of doing work. Power star. Power అంటున్నాం. Rate of power means rate of doing work. Rate of doing work. Rate means what? Cost? No. Rate of doing work. Rate means time. Rate means time. ఇక్కడ రేట్ అంటే టైం. తక్కువ టైంలో ఎక్కువ వర్క్ చేయాలి. ఫర్ ఎగ్జాంపుల్ 2 ట్యాంక్స్ ఆర్ దేర్ and 2 motors are there, same capacity. So motor A filled in 5 minutes, motor B filled that same tank in 10 minutes. So which motor has more power? Means first tank A. fast motor A. Why? Because it takes less time. It has taken only 5 minutes to fill the tank, but another B motor, it has taken 10 minutes time, means it has taken more time to finish the work. Who finish in less time, those persons or those machines, those motors have more power. Okay? Yes, you can take so many examples. Rate of doing వర్క్ చేసే రేటు అంటే టైంతో పాటు రిలేటెడ్ ఉంటుంది అని అర్థం. ఓకే, సో నెక్స్ట్ పవర్, పవర్ డినోటెడ్ విత్ పి అండ్ హియర్ పవర్ ఈజ్ నథింగ్ బట్ రేట్ ఆఫ్ డూయింగ్ వర్క్, దెన్ వర్క్ డన్ ఇన్ యూనిట్ టైం అన్నమాట. ఓకే, సో వర్క్ డన్ యూనిట్ టైం, దెన్ వర్క్ బై టైం వీ హ్యావ్ టు రైట్. So work we denote with W, time we denote with T, power P is equal to W by T is the formula of power, and SI unit of work is joule, and SI unit of time is second, and SI unit of power is watt. So 1 watt is equal to 1 joule per second. So SI unit of. Okay children, yes. Next, what moreover we have to discuss here? Then energy is equal to what we can write here? Work or energy. We can write work or energy. Work or energy. Energy by time also, work by time also. Next, here from this what we can write? W is equal to P into T, or work is equal to power into time, or energy is equal to power into time. Power into time also you can write the formula. Okay, yes. Next, here kilo means 1000, 1 kilowatt means 1000 watts, units of power finished. Mega means 10 power 6, kilo means 10 power 3. Okay, differences between work and power. As per your textbook, work done by a force is equal to the product of force and displacement moved in the direction of force. Just direct definition, work definition. Work is nothing but product of force and displacement. And next, power definition is rate of doing work. No? That is the first point. Second point is work done does not depend on time. In work, we don't have time. Work is equals to force into displacement only. There is no time here, but power, it depends on time. Power formula, there is time T, and SI unit is, this SI unit is joule, and the SI unit is joule per second or watt also we can write. So these are the differences between work and power, same as you can write, learn energy, differences between energy and power also, and some problems also there. Only it's very simple. How I told you, GFF SSC, given find formula, like that you have to do it. Okay, what is given, what is find, what we have to found, and substitution, simplification, conclusion. In this way, by using SI units, then you identify the concerned physical quantity from the question. I hope you understood. So thank you for listening, and do subscribe for more videos. I am signing off.